I'll share my screen and start the presentation.
So welcome to the first presentation that's sponsored by the Sustainable Resource Committee. The Sustainable Resource Committee is a group that is sponsored by the local spiritual assembly of the Baha'is of King County North. And the purpose of this committee is they're dedicated to promoting sustainable community environments within the greater Snoqualmie Valley. And they're looking towards the future, they're looking towards sustainability so that we can not only just survive on this planet, but thrive on this planet and make this wonderful, vibrant and active and peaceful planet for us and the generations to come. So this committee is committed to relationship building among people and groups, as well as among people and nature. One of the groups that they connect with are, some of the groups that they connect with are farmers, educators, academics, and also indigenous cultures. And we're blessed in this region to be among these cultures that have been here for so many thousands of years and know this area because of the vast experience they have here. This talk is provided as a free talk, and it's a series of activities that are working towards our goal of building a sustainable community in the Snoqualmie Valley. Today, our speaker is Demarus Tevuk. She develops educational content for crown bees and has been raising native mason bees and teaching others how to raise them for the past 4 years. Demarus has an intimate knowledge of the definition of sustainability from the Native American perspective with strong ties to the local Native American communities. I think at the end of this talk, you will, whenever you feel the urge to hug a tree, you'll also want to hug a bee. So with that, I'll turn it over to Demarus.
Thanks, Karish. Let's see. Okay, I've never given this presentation with Zoom before, so hopefully. So I'm going to go through the presentation, and then at the end, if you have any questions, we could have a little discussion. We could do a little Q&A at the end. So I like to start at the beginning of time and give a brief history of bees. So ants and wasps share a common ancestry. And for both of these insects, the larvae need a source of protein in order to develop into an adult. And around 135 million years ago, a wasp became vegetarian by gathering pollen as a source of protein, fat, and vitamins for the larva. And adult wasp and bees, they both drink nectar as a source of energy, but it's the larva that needs to eat the pollen in order to grow and develop into an adult. And so flowers and bees evolved together over all of this time. And now today we have a really big diversity of bees. Sorry, this is going forward without my, because I recorded narrations for something else. So now we have this really big diversity of flowers, and now we also have a big diversity of bees. So this is what bee diversity looks like. That's a giant carpenter bee on a quarter. So every bee has a role to play in our ecosystems. And this photo is courtesy of Joseph Wilson. He's one of the co-authors of The Bees in Your Backyard. And that tiny bee is a bee that's commonly found in the desert. So native bees, honeybees were actually brought from Europe. I'm trying to make this not autoplay. So, sorry. Honeybees were actually brought from Europe. A lot of people think that they were brought for pollination, but I like to point out they were probably most likely brought for honey for medicine and wax for making candles. Worldwide, there's actually at least 21,000 bee species. We're discovering new ones every year. And North America is home to around 4,400 native bee species, and Washington State has at least 600 bee species. And this book is one of my favorite reference books. If you want to know a lot about bees, that book has like 900 different pictures. So the first question that people always bring up when they learn about how many bees there actually are in the world, they ask, are all bees social? And actually, no, only 10% of bee species are social bees that live in hives, and 90% of bee species are solitary, hiveless bees. So I like to point out that social bees are the exception and not the rule for bee lifestyle. And if you can see this really thin wedge of the pie chart, that represents the 7 to 12 honeybee species there are in the world. So the way that bees live is most bees live very differently from honeybees. So how do solitary bees live? With solitary bees, every female bee is fertile and she's doing all of the work by herself. So she gathers nectar and pollen, builds a nest, and lays eggs. And because they have to do everything, solitary bees tend to be really efficient bees who stay really close to home. And because they don't have a colony or stores of honey and wax to protect, solitary bees tend to be really gentle bees. So where do native bees live? About 75% of those 21,000 bee species around the world are ground nesting bees. And even though they're solitary, sometimes they'll share the main tunnel underground, but they're still working on their own. They prefer to nest in grass or bare soil. And then hole nesting bees make up the rest, about 25% of bee species. But each female bee is claiming one nesting tunnel, nesting hole as her own. And they tend to nest in standing dead trees or logs. So this is how we can help with ground nesting habitat. Avoid landscape fabric, like the weed fabric, bark mulch, tilling, or spraying. Sorry, I have allergies and my nose is running. So if you want to give them a nice sunny spot that is bare and has low foot traffic, and they like to nest in sandy to grassy locations. And remember that they're only active for really a few weeks out of the year. So I tend to get a lot of people that say, we're worried about these bees in the ground, and I try to remind them they're only going to be adults that are flying for a few weeks out of the year. Their activity should slow down fairly quickly. So I usually don't talk about bumblebees during this talk, but I decided to add them because they are the only social bee that's native to North America. Washington State has around 23 different species. And bumblebees behave a little differently than honeybees because their colony size is a lot smaller. At most, they have around 200 bees per colony. And they're also different in that they have a new queen every spring. With honeybees, the queen can live 4 to 7 years, which is a really long time for an insect. And bumblebees, they will nest underground in an old rodent home or in an empty birdhouse. And another thing I like to point out about bumblebees is they tend to do this thing called flower constancy. So that means that once the individual bumblebee finds a flower that it likes, it will go to that same flower in a different location. Like it will go seek out that same flower. So that's one thing that makes them really good pollinators, because they're visiting the same kinds of flowers and helping that plant get pollinated. So these are the native bees that I know really well from my work with crown bees. And I realize some of these pictures might not be native species, but mason bees, leafcutter bees, and mass bees, they're all hole nesting bees. They're really easy to raise, and we can provide nesting habitat for them. So where do hole nesting bees live? I like to point out it's a bee house and not a hive. The bees nest in pre-made holes. Because their lifespan is actually really short, mason bees don't have the time to dig out a hole. They're opportunists. They have to nest somewhere that already exists. So they're nesting inside of dead wood, logs, broken grasses, or stems, or they'll nest inside of a pithy stem, something that's easier to dig out and remove than solid wood. And hole nesting bees prefer a diameter that's just right for them. You saw how the bees can come in lots of different sizes. The females, they only build one nesting hole at a time. They can fill more than one hole over their lifetime, but they're just going to work on that one until it's done. And this is how we can provide hole nesting habitat. You can leave standing dead trees, deadhead them, leave logs on the ground, or plant native bushes and grasses. Oops, sorry. If you have an annual flower that has a hollow, that creates a hollow stem, you can leave 12 to 15 inches of it pruned, and the bees will nest inside of that hollow stem. And I wouldn't even bother with cleaning up the dead stems because you don't know when the bees are going to be active and when they're going to come out. I'm going to talk about timing a little bit more. You can make healthy bee hotels. The Crown Bees website has more information about that. And we usually advocate for people to avoid drilled wood, bamboo, which is an exotic material, or plastic straws when you build a bee hotel, because plastic will hold moisture and that can cause mold. You're also most likely going to have solitary hole nesting, sorry. I'm not used to this pre-recorded stuff. The solitary hole nesting wasps, they hunt garden pests, and each wasp species has a favorite kind of prey that they like to go after. So you see the messy grass in here. That's a really common hole nesting wasp called the grass carrying wasp. They tend to hunt crickets. And then I think they just call this one a mud wasp. It's bringing home a caterpillar. So each wasp species has their favorite prey that they like to go after. I've even helped customers. They actually had a wasp where you could tell that they were eating spiders because they left the legs behind inside the nest. So the wasp, they have an important role to play with kind of maintaining pest population and even eating some of the other predators. So this is what's inside of a nesting hole. So instead of honey, sorry, I want to stop it from like skipping forward. So instead of honey, a pollen loaf feeds this egg all the way from egg until adulthood. So the nesting chamber is made up of some kind of protective wall, or the mother bee could gather materials like the leafcutter bees and build a cocoon to put the food and the egg inside and then close it all together. So one egg gets all of the food that it needs to grow into an adult. And with the nesting holes and the end also underground, the mother bee will start at the far end and move their way forward through the nesting hole. And at the very end, they make a capped end that's a protective extra thick wall at the outside edge. Sometimes the capped end is different than the protective walls, and that can help you kind of guess what species is nesting if you're managing a bee hotel. I really wanted to try to quickly explain how bee sex works. You can go back. So when a female egg comes from a fertilized egg, when the bee uses sperm and the egg together, that becomes a female bee. An unfertilized egg will become a male bee. So the mother bee is able to choose really easily the sex of the eggs that she's laying. And so with hole nesting bees, we know that they lay the female eggs towards the back in the more protected spot inside the nesting hole. And the female bees tend to be bigger, so they need more food. So the mother bee will provide a bigger pollen loaf for the bee. And I just wanted to bring that up because later on it's going to be an important thing to know. So now I want to talk about pollination effectiveness, because native bees are the original and best pollinators. So I'm going to go over a little bit about bee behavior and pollination effectiveness. So native bees are actually 100 times better, more effective pollinators than the European honeybee. With solitary native bees, each female bee over her lifetime lays at most 25 to 30 eggs. Some species can lay 50 eggs. But with a social honeybee, she lays at least 1,000, the queen lays at least 1,000 new eggs every day. Sometimes in the summer, this number can go up to 2,500 new eggs every day. With a solitary bee, because they're working on their own, they're efficient, they stay close to home, they only fly 300 feet every day. With a social honeybee, because the colony size is so big, they have so many new eggs every day that they need to feed. Every day they have to fly to a longer distance to a new source of pollen and nectar. With a solitary bee, because they're efficient, they leave the pollen loose and dry on their body. With the mason bees, they carry it on their belly. With the social honeybee, the pollen, they don't want to drop any of the pollen grains on that long distance flight home, so they clean themselves off and pack the pollen wet on this structure called a corbicula. People call them pockets on the hind legs. So I like to say that the solitary native bees are really good local pollen spreaders, and honeybees are actually really good long-range pollen carriers. Another thing that affects pollination is flight habits. With the social honeybee, they're organized, they're communicating with each other, they're really thorough and on a mission to get as much pollen as they can. And they're a long distance pollinator. So they can travel up to 5 miles or so from the hive to a single flower source. And there's evidence of honeybees being really meticulous about how they gather pollen, where they will remember and go back to the same plant. But with solitary native bees, remember, they're working alone, they're meandering in the landscape, and they're independent. Sorry. So they're visiting flowers that are ready to be visited. And they're really good cross-pollinators. So made this graphic to try to show that they're staying 300 feet and they're visiting a bunch of different sources. Like they use a lot of different cues that I won't go into today to determine if a flower is ready to be visited again. So now I'd like to cover bee life cycles. So this can help us understand when bees are active and how they're living throughout the year. Okay, so there are 4 main stages of development: egg, larva, pupa, and adult. And bee lifespans can be really short. Male bees are only really alive for a couple of weeks, and their goal is to mate. Female bees live longer for 4 to 6 weeks, maybe 8 weeks if the weather and conditions are really good. And I'd like to point out that bees are cold-blooded, so you won't see any bees flying until there's at least the daytime high of 53 degrees Fahrenheit. And then their activity will slow down in the fall once the weather starts to cool below 60 degrees Fahrenheit. So you really usually don't see bees flying in the fall and winter because it's too cold. So I'm going to go over the mason bee life cycle as an example of a bee that produces 1 generation per year. So in the spring, the bees are emerging as fully formed adults because they hibernated as an adult over the winter. And after mating, the female bees start building their nest. They're gathering the pollen and nectar, laying eggs, building the protective walls. And when the female bees are done nesting, the eggs hatch and the larvae slowly eat their pollen loaf. Because there's only one generation per year, it takes them a long time to do all of their development steps. And then around now, they're spinning cocoons and beginning to develop into adults. And they actually take a lot of breaks between all of the different stages, so that by the fall, by October, they've become an adult that's hibernating inside of a cocoon. And hibernating bees are surviving off of their stored fats. So here's the summer leafcutter bee life cycle, and they actually are able to produce multiple generations per year, similar to a honeybee. But with the leafcutter bees that we raise, we know that they require warmth to develop into adults, and that's called incubation, just like with a chicken egg. And so after that incubation, they emerge and start mating. They do the similar steps, pollinating and building the nests, gathering leaves to build the protective cocoons. And then the larvae hatch and they eat a little quicker, and they develop a little faster than mason bees, so that they go into incubation during the summer, and they go back to that first step of emerging and mating and building a nest. And with leafcutter bees, you can get 2 or 3 generations per year. But the late summer larvae will go into hibernation instead of developing into an adult bee. So those late season leafcutter bees are the ones that will hibernate over the winter as larvae and start the cycle again all over next year. Now I want to say that we should avoid lawn chemicals, because solitary bees, native bees, they have a short flying range. They are really picky about where they nest, and they won't nest in a place that smells like chemicals. The chemicals can deter them, the chemicals can kill them, and it can also impair them. I'm just going to talk about that a little bit more. Bee-safe chemicals were only really tested with the way that honeybees interact with the landscape. And I want to remind you that bees use natural materials inside the nest, or they're nesting underground. They're either bringing home something that could be contaminated, like mud or leaves, and then the pollen and the pollen loaf, the food for the larvae or the egg, could be right next to the larva. And I don't think there's really a good time to apply chemicals, because you don't know where they are, if they're nesting underground. And a good resource for getting to know alternatives, getting to know why you should avoid pesticides, is beyondpesticides.org. That website has a lot of information. They also have a lot of really good programs. So I'd like to introduce neonic pesticides. These are systemic pesticides, and they are applied to seeds before the plant begins to grow. They're based on, they're derived from nicotine, and they work on the insect's nervous system. So when the seed is coated, it gets absorbed into the plant, and it's in all of the tissues and in the flowers. It's in the leaves, it's in the stems and the roots. And neonics, they've been shown to impair the memory and learning of bees. Even, so bumblebees are the ones that they studied with neonics, and bumblebees have to forage from flowers that can be a little complicated, and like they need a little special work to get the pollen and to feed, but neonic pesticides can make it hard for them to learn how to feed from those flowers. Neonic pesticides have also been shown to reduce fertility in both male and female bees, and I'm not sure if, like, I haven't seen any research, but I'm wondering if a reduced fertility of male bees would mean that you don't get fertilized eggs and then you don't get female bees. I don't know if anyone's made that connection yet or looked into that. And the pesticides, they can persist in the landscape for years. It can take 7 years for the pesticide to leave. And this graphic shows that there's some studies that show that the neonics actually, they leach into the soil and into the water. There's been evidence of poisoning of birds, and also deer have been harmed by neonic applications. I also wanted to introduce, in 2017, there was a study that you might have heard of called, everyone called it the windshield study. They also called it the insect apocalypse. There is a 75% loss of insect biomass in nature preserves in Germany over a 27-year period. So they started looking at the data from 1989 and showed that there's this big loss of insects. And these are in natural places that are not supposed to be close to farmland or homes. So there's a lot of different reasons why the insect loss is happening. But I wanted to point out that we have a big responsibility and to take care of the land in our homes, because lawns can use 2 times more chemicals per acre than farms. And unfortunately, landowners, homeowners tend to not follow directions on the label and think if it says I should use this much, if I use twice as much, it's going to work twice as good. And that's not really true. So there are 78 million households in America, but we use 90 million pounds of herbicide every year on our lawns. That's just herbicide. That's not fertilizer or pesticides to get rid of insects. So now I'd like to talk about more about bee diversity, a little bit more about their activity, behavior, and the abilities that bees have to pollinate. So spring mason bees are special because they're the first bees to emerge in the spring. Remember, they hibernate as an adult so that they're ready to go. They fly in at least 10 degrees cooler weather than honeybees. They also fly in worse weather. And they're really built for spring because of that dark color. It helps them absorb sunshine and they sunbathe before they start flying. They're hibernating as adults, so they're ready to go as soon as the spring weather warms up. And they're using mud, which is like really readily available in the springtime. So they're using an available source to protect their nest. And this is a plum tree that was pollinated by honeybees. So alfalfa leafcutter bees, they're actually smaller than a honeybee. And the weight of the bee, when a bee lands on an alfalfa flower, there's a keel petal. When they land on it, the pollen hits them on the head. It pops open, hits them on the head. And honeybees do not like opening alfalfa. They will visit flowers that are already opened. So alfalfa leafcutter bees are 15 times more effective than honeybees at pollinating. And there's nothing special about them other than their behavior. And alfalfa leafcutter bees saved seed production. They were accidentally introduced from Europe in the 1940s. And alfalfa is a really important high protein source of plant material for livestock. And North America actually grows 2/3 of the alfalfa seeds all over the world. This picture is from the USDA. If you can see the spray of pollen behind the bee. So buzz pollination, some plants, the pollen is locked inside of a tube and the bee has to shake it loose in a certain way to get the pollen. So they either shake their head or their thorax to loosen the pollen and get the pollen to start coming out. So bumblebees, sweat bees, and carpenter bees are able to buzz pollinate, but honeybees don't know how to do it. And the plants that need buzz pollination are tomatoes, potatoes, eggplant, blueberry, cranberry, and lilies. And this is an example of evolution in real time. I think this was in Switzerland. They studied mustard plants over 9 generations, and the ones visited by bumblebees grew taller, they made more scent and UV reflection to attract the bees. The ones visited by Hoover flies became self-pollinating, and that's not good for plant genetics. And so pollinators can have a really big impact on plant physiology. And this is something that I think needs to be looked into a little more. When I started raising mason bees in my backyard, my perennial plants, my salmonberry plants, every year there would be more flowers. So there is something that happens when the flower gets pollinated. There's a hormone response that goes into the plant and sends a signal throughout the plant so that when they get pollinated consistently and pollinated really well, the plant responds, they remember, and they produce more flowers next year. So these are some steps to really save the bees. The most important thing you could do is grow native flowering plants. You can provide nesting habitats. I covered that a little bit. Really avoid lawn chemicals as much as possible. And I'm going to go over a couple local bee resources. So I'll go over the groups of plants that feed bees. Native flowering plants are 4 to 5 times more attractive to bees because they evolved with bees. They evolved together. The flowers and the bees evolved to work together. So the flowers provide they're either a really good source of nectar or a good source of pollen. You want to be careful with cultivars because they could, during the breeding process, they could lose the ability to make pollen or nectar. Food producing flowers, food producing flowers are also a really good group. So like stuff like apples, carrots, tomatoes, and anything that grows food for us is also attractive to bees and feeds bees. And then herbs or medicinal plants are also really good for feeding bees. So lavender, chives, thyme, rosemary, all of those plants are really attractive to bees. So these are some of my favorite native plants that I'd like to see grown in more places. Salmonberry blooms in the early spring. It's one of the first early native flowers. So it's good for bumblebee queens, the first bees of the colony, mason bees and hummingbirds. This plant likes shade to part sun. It needs it needs wetness when it's getting established. And it's a good plant if you need to do some erosion control. Trailing blackberry blooms in the early to mid-spring, a little later than salmonberry. It's good for bumblebees, mason bees, and it's a host to 4 different kinds of butterflies. This likes shade to part sun. It needs some moisture. You'll find it in areas where some trees fell, like it's a newly disturbed open area. You can train trailing blackberries on a trellis or a ladder, and if you get the chance to eat these berries, they're really good. They're really tasty. Actually used this plant as one of the grandparents for loganberry, I think. So the flavor is there. Thimbleberries, they bloom later in the spring. They're really good for bumblebees. And they're one of the few native plants that actually likes full sun. It can also grow in the shade, but they do need well-drained soil. I think the leaves on the thimbleberry are really pretty. And the berries are high in pectin. So if you need to make your jam stronger, set better. So common yarrow blooms from the spring through the fall. So it has a really long bloom time. And it's attractive to bees, wasps, ladybugs, and butterflies. and flies. Every time I find common yarrow, it's usually covered in some kind of insect. So this is a really good plant. It likes all kinds of conditions, poor soil, it's drought tolerant. There is a dwarf version of yarrow that would make a really good bee lawn. The dwarf version is also comfortable to walk on. So I wanted to talk about some nonprofit places that you can support. The Common Acre is based in Seattle. They have a restoration site called the Green Line, and that's where I took this picture of the purple lupine. They have a lot of wild bee education programs. They conduct local bee surveys. They also sell this bee identification guide that you can get. It's kind of like a folding guide that you can bring on your walks, and it's called The Bees of the Puget Sound Lowlands. It's a really good guide. It's really well done. And then the Xerces Society, I think they're based in Portland. They have a lot of pollinator plant guides that are organized by bioregion. And the bioregion guides, it includes bloom time, the plant's water needs, and then some tips for planting the flowers. And Pollinator Parkways is in Portland. You know the parking strip between the sidewalk and the road? They flip the strip. So instead of grass, they're creating native plant habitat. They're including logs as part of the design for nesting sites. The flowers, there's a free guide that you can look at on their website that includes native plants that would work well up here also. And then right now is Pollinator Week, and it's hosted by the Pollinator Partnership. And for work, we're doing a series of interesting facts about bees every day of the week. I'm posting a couple different ones. And there's so much more that I could tell you about bees. That's why I wanted to include on my last slide about how bees are able to count to 4. And so I will stop there. And if anybody has any questions.
I want to know how they count to 4.
I don't remember how the scientists figured it out that they can count, but I know they're able to, bees can also understand, you would like this to know all of this, Sandy. Bees know, they understand the number 0. They're able to do simple addition and subtraction, and they can count. And I think being able to count is a really important skill for a bee to have. We saw the like the front of the bee hotels, there's a bunch of holes, and they use visual markers to remember, this is my house, this is the one I'm working on. So being able to count would really help them know which house they're going to. Actually, I have one little show and tell. This is a bee observer. You see a bee filled this nesting hole right here.
Mm-hmm.
And I don't know how well you'll be able to see it. It's not going to show up because of my background.
Right there. Right there.
So on the bottom, there's the nesting chambers, just like that picture that I had before of the nesting chamber, the pollen loaf. These are mason bees that are alive right now, but they're in cocoons. So we can't see them anymore. They recently spun their cocoons. But this is really fun because you can watch them eat that pollen loaf and then start to spin their cocoons. And they're super slow, like they don't really go anywhere. They just stay in that little spot. So that's part of why I like to say we really should avoid chemicals, because the bees spend most of their lives hibernating or eating, or they're at some stage, and like we don't even know what they're doing, because each species has their season when they're active, and we still don't really know everything about what their timing is, how they hibernate, what kind of, if they make cocoons, if they use mud or leaves. There's still a lot of information that we need to learn about native bees.
So I'm confused, Demarus.
Mm-hmm.
How old do they get to be? Like 5 years old, or you
No,
just don't know?
no. So male bees, most of the solitary bees, male bees only live for a couple of weeks as an adult. So like with the mason bees, there's a whole year that goes from one cycle to the other, but most of the time they're sleeping, they're hibernating inside of the nesting hole, inside of their cocoon, and then they're only an adult for 2 weeks. They're only flying for 2 weeks. And then the female bees are only adults for 4 to 6 weeks. The only bees that live for a really long time are the queen honeybees. And that's because her job is to lay eggs, and she gets all of her food brought to her, and she's protected, and she doesn't have to fly. With our bees, the mason bees, towards the end of their life, their wings start to get tattered, and it's harder for them to fly. So each species has a little bit of a different life cycle. Remember that early slide of the giant carpenter bee on a quarter? Those are one of the only other bees that can live for a while, where the mother bees can live 2 to 3 years. And that's why they're the only bees that are able to chew through wood, because they're really big and they live for a long time. But they're going to reuse the tunnel as much as possible, because it takes them so long to build a nest. They chew 1/4 of an inch of wood every day.
Wow.
So a lot of the information, if you look for information about carpenter bees, it's mostly about how to kill them. And I don't like that. Like, they live for so long, they're reusing the tunnels, they have a really interesting way of living, they're able to buzz pollinate, and we need bees.
We had bees that lived in our house, on our porch. Was it last
Year, I think.
last summer or the summer before? But we worried about them, where they went, and if they were in there, and if they were going to come back, and they never came back. So did they all die in there, or did
I'm
they
not
move
sure. It might have, yeah,
Or-
it might have been that they tried nesting, and they decided that it wasn't a good spot, because people, if you were coming in and out of the porch, then they didn't, they want to avoid being next to people sometimes.
Now, why would they choose a place like that then?
Sometimes they're looking for a protected place that's dry. Like, so the porch seemed like a good idea, but they didn't realize how often people were coming and going.
They probably got in there before we started going out back and forth.
Yeah.
If they started getting in there early spring, then we didn't go out on the porch until early summer. Yeah.
But
I wanted to point out that the May 2020 issue of National Geographic is about the disappearance of insects. And
Yeah.
Yeah.
Oh, yeah.
here, you'll miss them when they're gone.
Yeah.
Is that backwards for you guys?
No, I can see it. Yeah.
I
that
wonder,
all caused by pesticides?
I was tempted to add a different graphic, but there's a bunch of reasons why insects are disappearing. Part of it is, especially in the nature preserves, it might be because of climate change, because insects are cold-blooded. So if there's a change in the cycle that cues them to come out when the flowers aren't ready, then they're not going to have what they need to eat. So that could be happening with insects too.
Demarus,
Donna?
I also wondered because it was 2017, and isn't that when the explosion of the Japanese nuclear plant happened?
No, this decline was, it was data from 1989 through
Okay,
to
then-
2016.
Oh, right, because Chernobyl was earlier than that, 1980, 82, somewhere in there.
Yeah, this study was in Germany.
Mm-hmm. I did.
Or are
hear-
there
Further
predictions? then?
questions?
Do you have predictions then, Demarus, of what's going to happen like 5 years from now? They're not.
I haven't seen any
Oh,
predictions.
we added down.
But a lot of the steps for helping insects are the things that I covered. So especially adding native plants to your garden, or if you have a patio, growing native plants. Native plants feed native insects. They feed local insects better than exotic plants. Much
How do
better.
you know a
Give
native
someone else-
plant?
Let's give other people a chance to ask questions too.
Okay, I'll stop.
So we're interested in what you're saying and what the answers to those questions are.
I should have
It's-
included there is the North American Native Plant Society has chapters for each state. So our Washington State Native Plant Society has a good list of native plants. And if you live in a different place, you can find the Native Plant Society for your state, and they usually have native plant guides. But that's part of why I like to point out the nonprofits that I cover in the end, because they're all doing work to help raise awareness about native plants and what you can grow in your yard or in your landscape or whatever you have access to.
Mary, do you have a comment?
Oh, you have to unmute
You're-
yourself,
you're
Mary.
muted, Mary.
I just wanted to, thank you. I just wanted to point out that the talk in July on the fourth Tuesday is going to be about native plants. Alex, who's the environmentalist that works for the Snoqualmie tribe, and another person.
Yeah, Bridget. Yeah, I'm getting the next month's talk lined up. It's going to be co-hosted by Alex Harwell from the she works as the environmental outreach coordinator for the Snoqualmie tribe. A lot of her projects involve native plant restoration. And then Bridget McNasser is the native plant program manager at Oxbow. And they're going to work together to help to give us a nice presentation about native plants
Hey.
next month. Huri, you have a question?
Yeah, I love the idea for planting flowers and specific ones that the bees will get attracted to them in our yard or something. Would it be safe though, as far as stinging? I mean, do they? I've always been afraid of bees because I think they're gonna sting me.
Yeah, I tried to explain that the solitary bees tend to be really gentle. They don't form swarms because they're not working together, they're working by themselves. The only time that a solitary bee will sting you is if it gets caught in your clothing, or if you're holding it and you're squishing it and it thinks it's about to die. It's like its last chance. And native bees don't have a barb, most of them don't have a barb stinger, so they're just gonna poke you and they're gonna live, like they're gonna be okay. They also, native bees don't make venom like a honeybee does. Like a honeybee is a special bee that has all of these things for a reason. And our native bees don't have those same reasons to have those defenses, so they don't. Anybody can, like with any kind of allergy, you can be allergic to anything. So there's no guarantee that you won't be allergic to native bees, but you can safely watch them. Like since I started working with mason bees and leafcutter bees, raising them, I'm not scared to watch bees on a flower anymore because they're on their own mission. They're doing what they need to do.
So,
Donna, do you want to go next?
You have to unmute yourself,
You're muted.
Donna.
You're muted, Donna.
You're on mute.
You're muted, Donna.
so how does their sting feel? Is it really
It's-
painful sting or pinch?
I've been stung by a mason bee on the palm of my hand because I was holding her and she was annoyed with me, and it was surprising. It hurt, and I was kind of like surprised, but it hurt for about 10 minutes and then it went away, and the next day I couldn't see where it happened. I was raspberry picking one year and a honeybee stung me on the tip of my finger, and that hurt for 3 days straight. So it's a big difference. Like the honeybees make the venom and it irritates you. The mason bees, native bees, they don't make the same kind of venom.
It probably matters where they sting you, and at the end of your finger has the most nerves. My question about the recording, where will this be available for others that may not have been able to make it tonight to be able to watch this? Because this is excellent, and I can't wait to show it to neighbors.
We are recording now, and then I think Demarus is gonna post it on her YouTube channel. So we'll send out a link. Maybe we can put a link in the same Facebook page where the announcement of the talk was, so people will have access to it. Thanks.
Yeah.
Excellent.
It's been a long time since I've used my personal channel, but I can host a video there.
Okay.
And I'll share it. Yeah. You have any more questions?
I have a question. On that, one of the first slides where you showed the little bee and the big bee,
Mm-hmm.
was the little bee the mason bee and the big bee the honeybee?
No, the big bee was a carpenter bee, which we don't really have in Washington State. Even though we have a lot of trees, we don't have carpenter bees that can chew through wood and live for a long time. So carpenter bees, they're about the size of a bumblebee, maybe a little longer. That bee was sitting on a quarter, so they're pretty big.
Oh.
And then the tiny bee is Paradita. That tiny bee is the size of George Washington's nose on the quarter.
Oh,
And
my
those bees tend to live in the desert. And we have bees of all kinds of sizes here in Washington State too. Before the talk started, Joy and Jim were telling me about how they have these little tiny bees that look like ants. Some bees are really small and they look like ants. And The Bees in Your Backyard is a really great book. It has at least 900 images of bees, and they talk about bees across North America, when they're active, where they nest, if they're like certain kinds of flowers. I didn't go over that. Some bees are generalists. That means that they'll visit all different kinds of flowers. And some bees are specialists, and they will only go to a certain kind of flower. So that's another reason why it's important to add native flowers to your designs, because the native flower that you have, it could be the plant that a specialist native bee needs. And there are endangered plants also. At the Green Line Restoration Site, they added Henderson's checker mallow, which is an endangered flower, and that just finished blooming this spring, but that's a really pretty plant. And there's things like the death camas bee. We are not cultivating camas like we used to, so we have less death camas, but there's a bee that only visits death camas. So we need all the different kinds of flowers. Yes, Donna?
Well, I was really upset with this landscaping company or the management because they came through and they sprayed some kind of material. They wouldn't tell us what it was. And then they took away all the dirt. And then I was worried I didn't see any bees. And I didn't see any bees and I didn't see any bees. And then finally, as you have said and taught me now, the temperature started to raise above, like one of the days, it was 49 degrees last week. And now it's up to 52 on a regular basis. And lo and behold, I'm starting to see some bees, both in the park as well as around here. And one of the things that happened on this, I think, non-native dahlia plant, it looked great, but there were little teeny bites out of the leaf, not all the leaves, but just a few leaves. And I wondered about that leaf-cutting bee. Is that like one of the signs that they're actually...
Yeah. I should really include an example of evidence of a leaf cutter. The pictures, they'll either do a full circular cut or it's an oval shape, but they only do it right on the edge, right on the outside edge of the leaf.
That's what I have. Yay, I got bees.
You have a question, Sandy?
Yeah, I do. What about this? You know, you hear in the news every once in a while about these giant killer bees or hornets or whatever it is that are starting to come to our continent. And so tell us a little bit about that.
Yeah, Asian giant hornets, they were spotted, I think on Vancouver Island is where they found live Asian giant hornets. And then I think they found, the ones that they found in Washington State, the first two were dead. So we don't really have evidence of them being established yet. But I did hear recently that they might have found another live one. I think the reason why honeybees are aggressive and have venom is because of Asian giant hornets, because there's videos of how the honeybees in Asia have a way of dealing with the Asian giant hornets by forming a ball around them and stinging them and fighting them. Our European honeybees don't have that predator, so they don't have that behavior to fend off the Asian giant hornets. You have something, Karish? You have to. Yeah.
There's also this issue of for the last 15 or 20 years, people have been talking about killer bees. Killer bees are a variety of European honeybees that are found in Africa, and they have made it over to America via ships and things like that.
Yeah.
So the African honeybee has made it to South America and Mexico, and I believe some of the southwestern states, Texas, Arizona, New Mexico. Yeah. But those bees really require very warm climates. They're not likely to make it to Washington State. Yeah, and they tend to have, the Africanized honeybees are very aggressive, and they tend to sort of attack in large numbers, whereas the European honeybees are not as aggressive.
Yeah. Yeah. I actually talk with the Washington State Department of Agriculture about the Asian giant hornets, and I just want to remind everybody, don't kill something first before you know what it is, because there's actually a lot of people that are killing bumblebees and thinking that they're killing a giant hornet, Asian giant hornet, and they're doing more harm than good. It's better to leave it up to the professionals. Like if you have a sighting, let the Department of Agriculture know that you might have seen them. But so far, I think it's been on the northeastern or northern part of the state is where they've been found, but we're not sure if they've established here yet. We don't know how they're going to behave either.
Yeah, aren't they so much bigger too? I mean, they're like 2 inches, and a honeybee is not that big. They're there's a big difference in the size, I think.
Yeah, And the Asian giant hornets are also, they're a social hornet, a social insect. So the way they behave is a little different than the solitary. But I still don't think that chemicals are the answer for getting rid of them. The state has a really good plan for monitoring them. They've got, if you want to participate, I don't know if it's really necessary over here, but beginning in July, you can set out trap nests for the Asian giant hornets, and you can monitor them. They have a special mix of orange juice and vinegar and stuff, a certain way to make the traps. So I think the state's doing a good job of getting the information out there and letting people know what to watch for. But I think it's better to leave it up to the professionals to deal with anything that might actually be an Asian giant hornet.
Okay, it's now 8 minutes after 8. Shall we thank our speaker, and then we can look forward to seeing her the next time. You're going to do more of these talks, right, Demarus? It was really, really informative. Thank you so much.
Thank you. Thank you, Demarus.
Enjoyed it. Yeah.
You're welcome.
Okay, thanks everyone.
Excellent.
Thank you so much. Thank you.
Excellent job. Excellent presentation.
Thank you.
Good night.
Thanks.